Right, for question 4bii, we have a tasty little question. Sec squared theta plus tan theta equals to 3. What you must recognize when you have an equation like this is that we have a squared here. We can form a quadratic when we have a squared, but obviously when we have these two, they're different. So we can't do it then, but always have the identities in your mind, identities that they form. So in this case, sec squared theta has an identity of 1 plus tan squared theta. We can assume that this is the identity that they want us to use because we have a tan theta there. It's all about what you assume. So we will say that this is the identity that they're using. So you have 1 plus tan squared theta plus tan theta equals to 3. You can see there's a quadratic because there's a squared, and then there's just it on its own, and then there's a number. We bring everything to one side, tan squared theta plus tan theta. Bring 3 to this side, minus 2 equals to 0. To make life simpler, we can just write as let tan theta equals to y. So we can let ourselves have a normal quadratic. So y squared plus y minus 2 equals to 0. And now it's just normal factorizing. Factors of minus 2, which add to give 1. That would be y plus 2 and y minus 1. 2 times minus 1 is minus 2. 2 minus 1 is 1. So now we have y equals to 2 and y equals to minus 2 and y equals to 1. Since we said tan theta equals to y, we have these two equations now in which we can find theta with. We'll start off with the 1, which is positive because it makes it easier for us. Use our cast diagram. When you pop in your calculator tan minus 1 of 1, you should get 45 degrees. 45 degrees, which is this one. Since we want the positive angle, since this is positive, 1 is positive, we want this angle, the all and the t, because it's tan. So to find this angle, it would just be 180 plus your 45, which is 225. Another way to find out these angles, other than the cast diagram, is if you draw the graph out itself in its whole. So a tan graph goes from -90 to 90, minus 90 to 90 I mean, and then it goes from 90 to 270, and then you keep going on. They had 45 lies over here. This is 1. So when tan theta equals to 1, you just go along. So this is 45, and then the next time it hits the graph, it's somewhere over there. Sorry, this should be 180, and 270 is the asymptote. .180 is where it crosses the line. So yeah, the next time it crosses the graph, that's at 225. Alright, so tan theta equals to 45 degrees, 225 degrees. In this minus 2 one, we're going to look at our cast diagram. Since it's a negative number, we want these two sections. This one and this one, because these are when tan is negative. To find these angles, First we're going to do the inverse of tan minus 2. Inverse of tan minus 2 gives you minus 63 degrees. Theta equals to minus 63 degrees, 63.4. Which we can basically say is the same as this being 63.4. To find this angle, you're going to do 180 minus 63.4, which gives you 116.6. And to find this one, it's 360 minus 63.4, which is 296.6. They wanted it in the interval of 0 to 360, as from part A. And so therefore, this can't be it. We can't have this because that's negative. That's not from 0 to 360. But all of these lie in the region 0 to 360. So this is your answer.